Hello everyone, I'm Koyan and today we are going to take a look on how to answer questions related to Form 4 Chapter 13, Homeostasis and Human Urinary System. So before I would like to enter, I was wondering whether are you actually struggling with some SPM concept? I mean not only biology lah, maybe in physics, chemistry, math. So that's a good news to you if you need tutoring lesson one-to-one to help you out with your weakest topic. So there's actually a non-profit organization called Tutors in Action. Yeah, you can actually check out to the website, Instagram page. I will put the link in description below if you are interested with it. So basically, we provide free tutoring lessons to students. And yeah, basically, if you sign up for it, you get paired with a tutor. And the tutor is mostly from SPM students, so they have experience with it. And yeah, I'm basically part of the tutor that is helping out. So you can actually try it out if you think, you are struggling currently and need some help. So don't forget to seek for help, your teachers, your friends, because we are all in the same boat. You are not alone, lah, basically. So now let's enter to this topic, this question. So it's just two individual with different situation. One is in a very air conditioned room, it's very obvious, and another one is in a scorching hot. So you can just straight away know that it's talking about the regulation of the temperature, body temperature. So they show you the skin right here and there is sweat gland or those. So which one is actually sweat gland? Sweat gland is actually this. The one where it's like curled up into a ball. Yeah, this is a sweat gland for your information. And then, okay, this one is actually your fine hair on your skin. So normally the muscle that attached to it is called the erector muscle. Yep, all right. And the others are, this is probably the arterioles blood vessels, okay? So they want you to explain your answer, okay? Complete the position of the hair for situation A. So how can you complete it? It's basically, what is the situation A going on? Yeah, it's in a very cold situation. So it's either that your hair will lie flat, very flat, or your hair will actually stand erect. So, okay, imagine you are in a very cold area. Okay, do you feel like those, your hair starts to stand up, that kind of goosebump, okay, goosebump effect? Yeah, your hair will actually, fine hair will actually stand erect during the cold temperature. So, yeah, you have to explain it. Basically, you stand erect. Okay, it's quite hard to draw, bro. Okay, yeah, it will stand erect. So how do you explain your answer is basically relating the erector muscle that causes the hair to stand erect. So what does the erector muscle do? So muscle is either contract or relax. So in a cold situation, your fine hair has to stand erect so that when all the fine hairs stand erect, they will actually trap the air. Okay, when you trap the air, it will get an insulation right here. So that's how it actually, yeah, insulate your body. So how you going to explain? You explain regarding to the muscle. Erector muscle contract, thus fine hair stands erect. All right, so how are you going to differentiate the structure P in situation A and B? So situation A is very cold and then B very hot. So structure P is regarding to this sweat gland. So you have to focus when it comes to sweat gland. Alright, so before I like to enter this, I would like to show you what are the physical methods to regulate the body temperature. So there are actually a lot lah. Got sweat gland, what happens to your arterioles in your skin, erector muscle, skeletal muscle, adrenal gland, and thyroid gland. So when your body temperature is above the normal range means your body is very hot. In your sweat gland, you actually get stimulated. Why do it get stimulated? Because it's stimulated to produce more sweat. So yeah, your more sweat will be produced. So why you need more sweat? Because the evaporation of sweat, it actually provides a cooling effect, right? Yeah. So basically, when it provides cooling effect, yeah, and the evaporation of it, it actually absorbs some heat that is from your body, and yeah, um, more heat get to release lah. And what about below the normal range? So below normal range means you are very cold. And you are very cold, you won't actually sweat lah. So sweat gland will be less stimulated and there will be less sweat produced. So yeah, lesser cooling effect because less sweat is evaporated from your skin because you want more heat to keep in your body. So yeah, that's how you explain for sweat gland. Meanwhile, for arterioles in the skin, when it comes to yeah body temperature very hot, the arterioles in the skin will actually get closer to your skin. The arterioles, right? Okay, let's say this is your skin. So your arterioles will actually get near to the skin surface there. Yeah, so you can see people when they are very hot, right? Their face actually flush quite red lah. Yeah. So yeah, so that more blood flow lah. When there's more blood flow, okay, beneath the skin right here, it actually get to release the heat out via radiation lah. And then most importantly is this thing called vasodilation. Yeah, vasodilation that will occur. And then for erector muscle, it will contract to stand erect lah. For your fine hair to stand erect, contract for your fine hair to stand erect. And for your skeletal muscle, during the hot situation, you won't shiver. So it actually just relax. It won't do anything. I mean, it won't really contract and relax lah. But when you are in a cold situation, you will actually shiver. So it will keep contracting, yeah, and relaxing lah. Then for chemical method is basically during a hot situation, you just want to prevent from generating more heat. So they won't actually get stimulated to. So there will either no or less hormone produced lah. So when there's a less hormone or no hormone produced, like the adrenaline hormone, thyroxine hormone, there will be less metabolic. So less metabolic means um lesser heat is generated. But when you're in a cold situation, the adrenal gland, thyroid gland is more stimulated to produce hormones, adrenaline and thyroxine, to increase the metabolic function. So when there's a metabolic function, your body temperature will instantly increase lah. So yeah, that's how you actually compare. So right here, when you want to focus on the sweat gland, because this only focus on sweat gland, you are going to say that the sweat gland is less stimulated, while in situation B, the sweat gland is more stimulated. So when the sweat gland, okay, so after talking about, okay, the main thing is you have to mention about sweat gland. Is it less or more stimulated? So after sweat gland, when it's less stimulated means lesser sweat produced. So you talk about the production of the sweat. So after production of sweat, um, if you want to further elaborate, you can elaborate on the evaporation of the sweat. Then you can talk about what happens to the heat. Is it released or is it retained in the body? But this one only consists of 2 points, 2 marks. So you just mention 2 points right here lah. So yeah, one is less stimulated and another one is actually more stimulated. Okay, since situation air A is very cold so yeah, they want to return back to original normal range. Yeah, they want to retain more heat in the body, so less sweat secreted, less evaporation of sweat, so more heat is retained. And when it comes to differentiate, you remember have to write the while this keyword and emphasize is in which situation lah. So yeah, for situation B is all the opposite way, more sweat is secreted and more sweat means more evaporation. So you have to emphasize with the word more or less lah. Then lastly, more heat is released from the body in situation B. So this is how you differentiate the structure P in situation A and B lah. What is the action of structure P? And now let's move on to right here. Suggest a way to produce more heat for individual in situation A. So it's just suggesting lah. Okay, so it's more of like out of the box question. You just mention like, oh, you can actually wear jacket. I mean wear a thick clothing. Yeah, so that's how you suggest only. Okay, wear thick clothing or cover with blanket. Yeah, because when you wear a thick clothing, yeah, you actually cover yourself, and then um there's a air layer of air trapped inside, so the air acts as the heat insulator lah. Yeah. Alright, now let's take a look at this volume of urine produced by individual in situation A and B. So you can see A, the volume of urine is a lot, and compared to B is quite less. So what is arbitrary unit is actually a unit where they don't want to mention it, whether is it volume or liter, so they just write it as arbitrary unit lah. Yeah. They just basically want to show you one is more and one is less. So explain the role of pituitary gland in urine production of individual A. So whenever you read question, don't quickly jump into the conclusion and just write the whole thing about urine production. You have to see this one is focusing on individual A condition. So you just explain regarding to individual A. That will save a lot of time and avoid from not answering the question in the end. So in individual A, since they produce a lot of um a more volume of urine, right? Okay, is how to say this? Okay, basically when there's a lot of a high volume of urine produced, is basically they want to release more more water from the body lah, because this one it actually produce more sweat. But this one, they barely even sweat lah, okay, very less sweat. So there's a lot of water retained in the body. In the body got a lot of water. So our kidney is the one that regulate the level of the concentration of those dissolved substance and our water, right? So since the body now got a lot of water, they want to, remove some of the water lah to regulate the blood osmotic pressure. So for this person, his blood osmotic pressure is actually lower than normal range lah. So when your blood osmotic pressure is lower than, do you actually see blood osmotic pressure is actually you see it through how much dissolved substance contained in their body lah. So since it has a lot of water inside its body, since it sweat very less, right? Means it has a very less dissolved substance. Since a lot of water that dilute it, so the dissolved substance containing inside the body is quite less lah. That's why less dissolved substance in the body means less blood osmotic pressure. Means, yeah, blood osmotic pressure lower than normal range lah. But for this person that sweat a lot, right? Remember when you sweat a lot, you go taste your sweat. It tastes quite salty, right? That's probably because some of the salt content dissolved substance is already lost lah. Okay, loss of those dissolved substance. So when you are loss of dissolved substance means loss of dissolved substance and a lot of water. Okay, most importantly, you think of this water with you lah. You lost a lot of water from your body. When you lost a lot of water from your body, means okay, this all your water lose out already. I mean not all lah, okay, some of your water lost out through sweat. So your body content right now has lesser water and higher dissolved substance. Yeah, so sorry for that. Okay. Higher dissolved substance in the body. Higher dissolved substance in your body. When you have higher dissolved substance in your body and lesser water content in your body, means your blood osmotic pressure is very high, higher than normal range. So when you want to compare blood osmotic pressure, you think of the dissolved substance. Okay. So for this person, he has a lot of water in his body content, means it's very diluted, means the dissolved substance is very less. So dissolved substance quite less in the body means low blood osmotic pressure. But for this person that sweat a lot, means a lot of water lose out from the body, the dissolved substance in the body eventually become very high dissolved substance since it has low water content in the body, since most of the water content is being lost from the body. So high dissolved substance means that high blood osmotic pressure. Yeah, I hope you understand this part. So how are you going to explain? So you have to mention like what is the role of this pituitary gland first. So in this situation, when your blood osmotic pressure, I just write BOP, is low, means that there will be a lesser stimulation in your pituitary gland. So pituitary gland, because you want to explain role of pituitary gland. So how do you explain at first? You just go straight to the point what happens to your pituitary gland. It is less stimulated. Why? Due to the low blood osmotic pressure. So when you want to say low blood osmotic pressure, you have to elaborate that it is lower than the normal range. Normal range, okay? So caused by blood osmotic pressure lower than normal range. So when your blood osmotic pressure lower than normal range, and then less pituitary gland less stimulated. So pituitary gland actually in charge on producing this hormone called antidiuretic hormone. Yeah. So now it is less stimulated, so there will be a less ADH will be secreted. So if you don't know how to spell the whole thing about antidiuretic, you can just write ADH lah. If you really forgot lah. Yeah. But the mask team just straight away write ADH lah. So if you want to be safe, you just write the full name of it. But if you really can't think of the full name or you scared you spell wrongly, you just write ADH will do. So yeah, it really depends lah. So less ADH is secreted. When there's less ADH is secreted, so the one, okay, the one that in charge in the, I mean, the absorption of water, right? This ADH actually acts on this wall of tubing, which is distal convoluted tubule, and the wall of collecting duct. So wall of distal convoluted tubule and collecting duct is less permeable to water since there is a less secretion of ADH. Because what is the function of ADH is actually stimulate the reabsorption of water from the body. But now it secretes less ADH, so there will be a less reabsorption of water. So results in a lot of water. I mean, a lot of water in the urine lah. So the urine volume will be more lah. So less permeable to the water. So less water be absorbed into blood capillary. So end up will be discharged. So that's how you relate to the urine production. Volume of urine produced by individual A is more than individual B. Individual B. Alright, so first of all, it's basically talking about what happened to the pituitary gland. It is less stimulated since it is caused by a lower than normal range blood osmotic pressure. So this one mark right here, one mark right here. So when its pituitary gland less stimulated, because its normal role is to secrete ADH, but now less already, so it secrete lesser ADH is secreted. Okay, and it causes when there is a more ADH secreted, it will cause the wall to be more permeable, but now less already, so it will be less permeable to water. When it's lesser permeable to water, right, it means the reabsorption of water is lesser. So this is how it actually like a story of it lah. Okay, and this results in the volume produced will be more than individual B. Yeah. So this is basically how you obtain your mark when it comes to explanation on blood osmotic pressure. Don't worry, later on we'll get more questions related to this blood osmotic pressure. So how the individual in situation B reduce the blood osmotic pressure back to normal. So means that his blood osmotic pressure is higher. Yeah, it's basically above the normal range, right? Since he sweat a lot, means a lot of water is lost from his body. A lot of water lost from his body got a lot of dissolved substance, or since a lot of water is lost. So contain a lot of dissolved substance. A lot of dissolved substance indicates higher blood osmotic pressure. So how can you actually reduce back to the normal range? Okay, normally when you lose a lot of water, how can you recover it back? Is through drinking lots of water long drink. So yeah, you just think logically lah, normally in this type of situation. Okay, so let's go to this question right here. I I think I pasted it in the wrong chapter lah. Is yeah. So this one is actually talking about the health issue related to human endocrine system, but it's okay. I'll just discuss it also. So one of the guy is shorter in height, abnormally shorter lah. Not quite short, it's abnormally shorter lah. It's 122 cm only, unfortunately, even though they are at the same age. So explain the effect of hormonal imbalance that cause the physical condition of new S. So basically this guy experienced dwarfism. Yeah. So what is actually causing it to occur is basically because of the growth hormone. So how do we actually grow tall? One of the most important hormone is actually this thing called growth hormone. But this guy, he has a very less, abnormally less secretion of growth hormone, maybe due to genetic issue. So, especially during puberty, you have a higher secretion of growth hormone to stimulate your growth of the bones, so for you to grow taller. But he tend to have a lesser growth hormone, so it actually will delay his growth of bones, and then yeah, his height is basically very short lah, lower lah. So what is the effect? You can straight up mention what is this health issue. It's actually dwarfism. He is currently experiencing dwarfism. That's how you actually get the first point. And then how is it? I mean, what causes dwarfism is due to a low secretion of growth hormone. That's the second point you can actually mention. So other than talking about low secretion of growth hormone, okay, growth hormone actually stimulates the growth, right? Growth of the bones. So now it's less already, means it will less growth of bones, or it delays the growth of the bones. Yeah. And during the secretion of hormone, you can also emphasize that is during the puberty period of growth. And last but not least, maybe you want to mention what is actually dwarfism is whereby his height tend to be lower than a normal male adult lah. So that's how you actually get these 4 points to explain to it. One, talking about dwarfism. What is the condition of dwarfism means his height tends to be lower than normal male. Why dwarfism will occur is because of lesser growth hormone secreted. Point already lor. Then maybe you can emphasize during the growth of period of growth, and maybe you want to say that because of less growth hormone it will delays the growth of bone, because the function of growth hormone is to stimulate the growth of bones. So because less now, so it delays it. So basically this is how you actually answer to the question right here. Yeah, so that's basically what I mentioned lah. Other than that, you can also mention organs uh, fail to develop is a bit scary lah, but um not fully developed means not fully also very hard to say. Um Basically the organ tends to be small size lah, not developed until like, until very big. Okay. So the parts of the body ratio remain as that as a child. Yeah. Okay. And the height. Most importantly, you mentioned about what happens to the height. So for now, we are going to look at this formation of urine, which is what students always fear about. I also tend to be afraid of it, but don't worry. Let me guide you through it. So yeah, I understand this one got a lot of process happening and all the substance right here. So first of all, before I enter, I like to introduce you what is the structure. I know there's a lot of structure, a lot of process, a lot of dissolved substance, passively active transport, a lot of major process. So yeah, before I enter, I would like to show you which part is which part. So basically, T is your glomerulus. So it's actually like a ball of blood vessels right here. Yeah, a ball of it. So it's actually a glomerulus. So during the glomerulus part, okay, some of it will be, yeah, entering the Bowman capsule. So this one is called Bowman capsule. The man bow down, so Bowman capsule. Okay, so maybe some of the fluid get to pass through it and then become a Bowman capsule. Sorry, glomerular filtrate. Okay, I'm not going to mention that in detail first. So this one is just the renal vein lah. this is all the blood capillary. The one I didn't shade in yellow is actually the blood capillary. So, basically we need to absorb some substance for our body use, right? So it will be absorbed into your blood capillary. Okay, followed by this Bowman capsule, it actually leads to your renal tubule. So renal tubule, they actually branch out into three types. Because a lot of students get messed up. What is the difference between renal, proximal, loop of Henle, distal? So many type of tubule. Ayo, very hard to understand. Okay, so renal tubule is actually a general term. It is a general term. So if you want to be specific on which part, is it the starting of the renal tubule or at the middle or at the most last part? Okay, it's actually proximal is the starting of it. So proximal followed by loop of Henle, then distal convoluted tubule. So I'm going to wait now. Okay, so this part after the Bowman capsule, you actually lead to this thing called your proximal convoluted tubule. Okay, after your proximal convoluted tubule, you can see that now it is a loop, right? A long U shape right here. So it is actually entering your loop of Henle. So after the loop of Henle, you go back into this part. Okay, you are actually eventually approaching to the last part right here. So before entering the collecting duct, it looks like a bamboo stick, but not bamboo lah. But basically, you can see it's just one stick right here. So this one, then got this small thing like branching out a bit lah. But it's basically your collecting duct right here. So before entering your collecting duct, you actually reach to your distal convoluted tubule. This is the last part already. Distal convoluted tubule. So sorry. Okay. Distal convoluted tubule. Alright. So first of all, imagine you are the blood plasma and then you are entering. Okay, first of all, I enter the glomerulus. And then my size is small enough that I can pass through it. So I can, okay, first of all, there will be afferent arteriole and then branch out into efferent arteriole. But later on, I mentioned about it lah. So afferent and efferent, their diameter is different. Afferent tends to be larger, afferent arteriole, and efferent arteriole, it tends to be a smaller diameter. So when large to small, can you see that there is a pressure difference? Yeah. So it leads to a hydrostatic pressure right there lah. That's the reason why some substance are forced out into the Bowman capsule, especially small size substance. Except like red blood cell, platelets, those are too large, so it won't be forced out. So due to high hydrostatic pressures, some of the stuff will be forced out. So yay, now you are small size enough, you can enter the Bowman capsule. So after entering your Bowman capsule, you go to a roller coaster ride. So which is entering your renal tubule. So renal tubule got three things. First of all, you enter the starting of it, proximal convoluted tubule, and then followed by loop of Henle, which is a one whole loop, one whole due right there is a loop of Henle. And last but not least is your distal convoluted tubule. So this three is actually a renal tubule in general. But when you want to be specific, you can say it's the proximal or loop of Henle or distal. And then last but not least, you will enter this collecting duct right here. So that's the last part where in the end, the formation of urine will occur, like those substances not get to absorb and water that you know yeah so ended up all those substances tend to become the formation of urine, though the liquid in your collecting is the formation of urine. Ta-da. Yeah. So now let's take a look in a more detailed manner what actually happening through all this situation. So there are actually three main process you have to remember. So what are the three main process right here? I understand I wrote a lot of things. It looks very messed up. Okay. Okay. So first of all, it will actually occur this thing called ultrafiltration. Okay. Especially in between your glomerulus and Bowman capsule, this is where ultrafiltration occur, not Ultraman. Okay. Then followed by this part is where a lot of things will be absorbed into your blood capillary network. Because you need some substance, you need to absorb something for your blood capillary ma. Not everything will be passed out as urine ma. Something you need to some nutrients you have to absorb it. Okay, I mean some dissolved substance lah. So to regulate your water content. So here is where reabsorption occur. During your renal tubule, reabsorption will occur. Alright, followed by secretion. So the third one is secretion. Secretion is actually the opposite of the reabsorption. Okay, what does it mean? So reabsorption means you reabsorb some substance inside into your blood capillary network. But secretion means your blood capillary don't want that thing. So they secrete all the waste substance out from the blood capillary to the collecting duct and distal convoluted tubule. So they actually secrete out all these things lah. Later I will mention in detail. Okay, so yeah, so many process to remember. Which one is actually the most important? The most important is actually the ultrafiltration. I would say this lah, because most of the time they like to ask about ultrafiltration because that's the easiest to answer lah. If it's a very long essay question, then probably want you to explain the whole situation, whole three process. But normally they just focus on ultrafiltration, so you have to take a note. Okay, at this ultrafiltration part, what actually happens right here is basically okay. Your blood, right? You enter the glomerulus in a high hydrostatic pressure. It will enter in a high hydrostatic pressure. High hydrostatic pressure. So why it enters in a high hydrostatic pressure? I know the color a bit chechat. Okay. Why it enters in a high hydrostatic pressure is because there is a difference in the diameter of afferent arteriole and efferent arteriole. So sorry, it's a bit lagging. Okay, so the afferent arteriole is actually larger. Yeah, so it is larger than the efferent arteriole. Okay, so first of all, blood enters your glomerulus. Yeah, okay. Blood enters your glomerulus under a high hydrostatic pressure. Why high hydrostatic pressure? Is because your diameter of the afferent arteriole is larger than the diameter of the efferent arteriole. Okay, so because large go to small, right? You can imagine the pressure. There's a pressure difference, so which results in a large pressure difference. So that's why high hydrostatic pressure. So high hydrostatic pressure will cause a pressure. Pressure means you push, right? So if you actually push something means it will pushes the fluid So the fluid it will actually seeps through the wall of okay, it will seep through the wall of glomerulus into the cavity of Bowman capsule. Okay, so I use another pen right here. Okay, so basically your fluid, it will seep through, means kind of like diffuse lah. Okay, it will seep through the wall of glomerulus to the cavity of Bowman capsule. The content right there lah, so the area right there, so it's called cavity of Bowman capsule. So now you enter the Bowman capsule already. So now the fluid, initially the fluid in the glomerulus is called glomerular filtrate. But now it and yeah, so yeah, because it is from a glomerulus, it is actually called a glomerular filtrate. Yeah. So now you can actually mention what consists inside a glomerular filtrate. What got inside the what is inside lah. So it is actually, you can just say that because the red blood cell platelets plasma protein has a larger size, so it can't pass through the wall of glomerulus into the cavity. So it's basically like you are mentioning the process of human lymphatic system because of high hydrostatic pressure, right? So it's actually almost the same content lah. It's basically, it has the same composition as a blood plasma, just that no one, it does not have the red blood cell, no platelets, no plasma protein. It's actually quite similar to what you learn in human lymphatic system now. Because they are too large, they can't pass through it. So they actually remain inside and then pass inside your blood capillary lah. The red blood cell platelets, it won't pass through so it won't become a glomerular filtrate. So glomerular filtrate does not have red blood cell, no platelets, and no plasma protein. So in conclusion, a lot of points right here in just one ultrafiltration. So it's basically ultrafiltration occur. Why? Blood enters the glomerulus under a high hydrostatic pressure. So why high hydrostatic pressure is because of the diameter of the afferent arteriole is larger than the efferent arteriole. So high hydrostatic pressure leads to your fluid will seep through the wall of glomerulus into the cavity of Bowman capsule. So after it enters, the fluid in the Bowman capsule is called glomerular filtrate. So glomerular filtrate, what does it consist? Is actually almost the same as blood plasma, just that no red blood cell, you emphasize, does not have red blood cell, platelet, and plasma. So this is the main process that occurs in the ultrafiltration process. So followed by, now the glomerular filtrate, it enters the proximal convoluted tubule loop of Henle. So during this case, during this process, is where reabsorption will occur. So what are the things we actually absorb into your blood capillary? Why the blood capillary wants it? So the things that will be absorbed is actually five main things lah. The five thing right here is actually this: glucose, amino acid, so Na plus, chloride ion, sodium ion, chloride ions, and water. So these are the five things that will be reabsorbed in your proximal convoluted tubule. At the proximal convoluted tubule right here. So here are the five things during the reabsorption. So glucose and amino acid is 100% absorbed. Yeah, it is completely absorbed because you need glucose, right? You need amino acid, right? For synthesis of protein, all this. Yeah, that's the reason why it is 100% absorbed into your blood capillary. Other than that is your sodium ion. So it will be actively pumped into your blood capillary. But for chloride, it's actually a bit different than the other three. It is passively absorbed lah. passively transported, passively like in a passive manner. Okay, so when a lot of things actually get absorbed, right? Okay, let's say lah, at here you zoom in bigger. Okay, so okay, sodium ions, the glucose, amino acid, so all enters your blood capillary. Blood capillary. The absorption occur. So 100% of 100% of glucose and amino acid are absorbed, and then sodium ions and sodium ion is actively, and then chloride is passive manner. Okay, so now you got a lot of this thing, glucose, amino acid. So when there is a lot of this dissolved substance in your blood capillary, means that you have a lower water potential, right? Because now your blood capillary consists of a lot of sodium ions, glucose, amino acid, blah blah blah. So means that it has a high solute potential but low water potential. So can you imagine what happens to your water? So water, it will move from a high water potential to low water potential, right? So the water will actually also be reabsorbed into your blood capillary network, because here right now it has a high water potential, so it will diffuse via osmosis manner into your blood capillary, which has a lower water potential. That's why there are five things are being reabsorbed, which is glucose, amino acid, sodium, chloride, yeah, and water. So water explanation is because of the difference in the water potential lah in your blood capillary and the proximal convoluted tubule right there. Okay, so followed by this loop of Henle is basically further reabsorption occur lor. So it's actually, sodium ions will get actively absorbed, and then water it really depends on the content, but yeah, basically most of the time it will be reabsorbed. And then yeah, after the loop of Henle, it goes to your distal convoluted tubule. So there also will occur reabsorption lah. So reabsorption, it actually occurs along your inner tubule. Yeah. So yeah, reabsorption occur, but the proximal convoluted tubule, they explain in more detail lah, because that's where the part where your glucose and amino acid are 100% absorbed. Then loop of Henle distal convoluted tubule is just sodium ions, water, all this being reabsorbed, but it will depends on the content of your body lah. Maybe now it lacks of water, then maybe it will be reabsorbed more lor. Or maybe it lacks of this dissolved substance, then it will be reabsorbed more. So it depends on the situation. So alright, right now the third major process is actually your secretion process. So secretion process is the opposite of reabsorption. Just now reabsorption is the substance from your renal tubule reabsorbed into your blood capillary network, because your blood capillary, your body needs it. But now your body doesn't need something. They will throw out some waste bacteria. They don't want all these things. So they want to discharge it through urine. So how do they discharge all these things? Is actually through this major process called secretion. So from the blood capillary, they will discharge, they will secrete out. So it's opposite. You can see the arrow right here, secretion, is from the blood capillary go inside the collecting duct. From blood capillary go inside the distal convoluted tubule. Just now is from the renal tubule reabsorb into your blood capillary. But now it's from your blood capillary, you don't want it, so you secrete out to the distal convoluted tubule collecting duct. Yeah, it's secretion process. So secretion process actually occurs along the renal tubule and collecting duct. But most active is actually your distal convoluted tubule and your collecting duct. So these two are the most active situation lah. This one is most active, like distal convoluted tubule. So secretion is basically you want to get rid of those waste material, because our kidney not only regulate the salt and water content, it also want to discharge the waste material out of your body. So there are these things, waste material, which will be secreted out through simple diffusion and active transport. So there are some example like ammonium ion, urea. So urea is actually the product, like deamination. When your body has too excess amino acid, it will be broken down via deamination process by your liver cell lah, by your liver, to become a urea. So this urea, I mean, it's toxic ma, so it'll be secreted out. So this is what happens to your urea lah. It'll be secreted out and be discharged in the form of urine. So other than that, got creatinine, got drugs. So that's the reason why in your urine, it most probably contain all these waste bacteria lah. Other than that, it's your water lor. Yeah. So secretion occur most active in the distal convoluted tubule, and also collecting duct. That's where you get rid of your waste material. Okay, and now it will be formed as a urine. So your body very king lah, they know which one is toxic. So yeah, so you can see right here, if you got consumed drugs, right, eventually your body don't want all this drug ma, so they will actually secrete out, they will get rid the drug. So in order to see whether the person got take drugs, is actually through urine test law. They will test their urine whether it contains this drug content lah. Yeah, because if you got consumed drug, of course your body will go and secrete it out, get rid of this drug. So now it becomes urine. Then you do the urine test, you found out got drug, means you got take drug law. Yeah. Okay, another situation is they sometimes you ask K-Bug question like, why the person urine contains glucose. If it contains glucose, means probably means this person got diabetes lah. Okay. Yeah. If the urine got glucose, right? Yeah, that person is probably diabetic. It's because your glucose content in your body too much that your body memang cannot 100% reabsorb back lah. So some of the urine eventually get discharged. But this is a normal situation, is where diabetic patient. But in normal case, it will be fully reabsorbed. So your urine won't contain glucose one. Just that diabetic patient, there will be glucose present in the urine. Yeah, that's some K-Bug question lah, they sometimes will ask. So yeah, now I hope you can understand right here. Okay, I know it's very long. Okay, so first of all, it's ultrafiltration. Why ultrafiltration? High hydrostatic pressure. Due to difference in the diameter, one is larger or efferent is larger than efferent. Efferent come first because A first ma. And then some of the substance get to seep through the wall of glomerulus, enter the cavity of Bowman capsule. So the fluid in the Bowman capsule called glomerular filtrate, which is quite similar composition to blood plasma, but does not have red blood cell platelets and plasma protein. Then followed by reabsorption process. So most importantly is these 5 things that happen in the similar convoluted tubule that get to reabsorb is 100% of glucose and amino acid, because you need it, so it will be 100% absorbed. Then followed by sodium ions actively, and then chloride is the passive one lah. Then because of the difference in the water potential, that will lead to reabsorption of water via osmosis. And then in the loop of Henle is sodium ion active, and then water osmosis. Then the distal convoluted tubule reabsorption is also depends on the situation lah. Sometimes, yeah, maybe more reabsorption. Okay. Then last but not least, you want to get rid of your waste material is where secretion occur. Then yeah, all these waste substance will be secreted out in form of the urine. So that basically sums it all. So 3 main process is just basically the ultrafiltration, the one I wrote in purple color, ultrafiltration, reabsorption, and secretion. So how process in tea actually occur? So it's basically this thing. okay, under high hydrostatic pressure. Why high hydrostatic? Diameter is larger. Yeah, and leads to fluid seep through wall of glomerulus into the cavity of Bowman capsule. Now, what the fluid name called? Glomerular filtrate. What contains in glomerular filtrate? It has the same composition of blood plasma, but what does it not contain? Beta cell, platelets, and plasma protein. Okay, roadblock, a group of guy gets detained, and then urine was tested with drug urine test kit, and then positive means the urine got cannabis. So, based on biological knowledge, how cannabis can be detected in his urine? So, it's basically relating to what? The secretion process that occur in most actively in your distal convoluted tubule. So, yeah, because you got take the drug, I mean the cannabis, then because cannabis is actually considered as a toxic substance or waste material, so it be secreted out. That's the reason why in the urine there will be presence of it. So secretion occurs during formation of urine. So most importantly, you mentioned secretion. Why? Because like waste materials, which is not filtered earlier into the renal tubule, it will be secreted the most active in the distal convoluted tubule and followed by, yeah, secretion get rid of toxic waste such as your cannabis, the cannabis. So it is present in the urine. That's why it's present in the urine. So when you are writing all these essay question, you have to write it in a paragraph form. It will be clearer for your examiner to mark lah. Don't write in point form. Okay, I know I always write in point form for you to see like which point get marks, but please don't write in point form. Okay, in essay question, structure question also don't write in point form lah. Yeah, don't write in point form. Okay, so for essay you write it in a paragraph form, like 2 to 3 points, then you make another paragraph. This will be very easy for your examiner to mark and won't miss out some of your points you have mentioned lah. Because if you write a lot of things in one paragraph, they very hard to spot your answer. Yeah. And this one is actually talking about blood osmotic pressure. Describe the difference. So of the mechanism for the return the blood osmotic pressure back to normal range. So can you actually mention the mechanism to regulate the body temperature? Like you say, oh, more sweat produced, less sweat produced because you focus on the sweat. No, please don't ever mention body temperature in this question because they talking about blood osmotic pressure. So if you write about the mechanism to return the back to the body temperature, no, you won't actually get marks. You just end up wasting your time. Just focus on the blood osmotic pressure. Although the picture is quite tricky lah, they got show you this guy is sweating. But this guy sweating doesn't mean you have to mention about regulation of body temperature. This one, they already emphasize it is blood osmotic pressure. Unless they didn't mention that, then you can write it through blood osmotic or blood body temperature. But this one, they already emphasize blood osmotic pressure. So they only give mark if you explain about blood osmotic pressure situation. So you just put focus on that. Okay? Don't waste your time on explaining others. Okay, so you have to describe the difference. So when it comes to essay question, it is better when it comes to compare contrast differences ma. Write it in a table form. This will be better for your examiner to mark and for you to answer because sometimes you scared when you differentiate that stuff, that specific aspect, you forgot to differentiate the other guy. Like you differentiate situation A, you got talk about situation A, but you forgot about situation B. So I suggest you write in a table form. So table form, you draw a table, got two things to compare. One is situation A, one is situation B. So um you just write the main thing at the top of the table is situation A. The second one is the situation B in the second column. So this guy right here, it is a rainy day. So in rainy day, Mr. Zack sweat less. In hot day, Mr. Zack sweats a lot. Means it lose a lot of water lah. Man, a lot of water. Okay. So when you lost a lot of water, okay, or the lost many water, okay, means your body right now has less water, a lot high concentration of dissolved substance. So dissolved substance, you can straight away when it's a high concentration of dissolved substance means you have a higher blood osmotic pressure than the normal range. Okay, for this guy right here, oh, he barely even sweat lah. So means a lot of water still retained in his body, and the dissolved substance also, it get kind of like diluted. I mean, diluted a lot of water in his body lah, basically. So means he has lesser solute lah, because a lot of water compensate it already mah. So now means that it has a lower blood osmotic pressure than the normal range. The situation A is higher blood osmotic pressure. Okay, so causes blood osmotic pressure drops or increase above. Okay, I focus on this sweating guy first. Okay, okay. After you mention about blood osmotic pressure, okay, it will actually stimulate. Okay, when your blood osmotic pressure deviates from the normal range, a receptor will actually get this signal like, oh, your blood osmotic pressure increase above normal range. So the receptor will be stimulated lah. Okay, after the receptor stimulated, right, then it will pass the info also to your pituitary gland. So yeah, osmoreceptor. What is the receptor called? It's called osmoreceptor. I know got nociceptor, osmoreceptor. Actually got a lot lah. Yeah. This one is talking about osmotic pressure. So this receptor, in specific, their name is osmoreceptor. Osmoreceptor in the hypothalamus are stimulated. Okay, if this point you can't remember too many receptor, then yeah, it's okay lah. Because this one 8 marks maybe lah. You can just talk about straight away mention what happens to your pituitary gland. So pituitary gland is stimulated. It's more stimulated lah. Because blood osmotic pressure increase, so leads to the stimulation. So pituitary gland is the one, after it gets stimulated, it will produce ADH, right? So it will secrete ADH, more ADH, emphasize more or less. And then when there's a more ADH secreted, what does the ADH do? ADH, it stimulates reabsorption of water, right? So how it actually causes more water to be absorbed? It actually will let the wall of distal convoluted tubule and the collecting duct to be more permeable to water. I know this one didn't mention collecting duct lah, but distal convoluted tubule and the collecting duct to be more permeable to water. When it's more permeable water means more water can get reabsorbed. More water, it will be reabsorbed. Yeah, they separate into 2 points to get 2 marks lah. Sometimes the mark scheme very good lah. But this one very hard to say lah, because you also don't know how the mark scheme will be like lah. So if you actually mention like distal convoluted tubule and collecting duct to be more permeable to water, maybe they just give you 1 marks only lah. But they somehow separated into 2 lah. This is very hard to say lah. I also can't predict how it's like lah. But you just basically write what you understand and the keywords lah. Yeah. Because if you somehow so ngam, you go separate them into 2 points, yeah, you can get 2 marks because the marks scheme give it in this way. But yeah, you just don't be too reliant on marks scheme lah. It's okay lah. You just write based on what you can remember and those points. That one I really hard to advise lah, because yeah, I'm not the one that come out the paper. And yeah, when more water is being absorbed, the urine produced, it will be low in volume. Low in volume means it's very gao, very concentrated. Yeah, very yellowish in color. But we normally just say concentrated and what's the volume. So in the opposite way, he sweat less. So his blood osmotic pressure is lower than the normal range, less stimulated of the osmoreceptor and pituitary gland. Less stimulation means less ADH. This hormone is very important, antidiuretic hormone. Okay, less ADH secreted from pituitary gland. Pituitary gland is the one that secrete it. So less ADH, it means that it will cause the wall of distal convoluted tubule to be alamak. Why this part is the same thing? Sorry. Okay. Oh my god. Okay. To be less permeable to water. So sorry for that. Yeah. I didn't expect the mark scheme to be wrong. Okay. Low ADH concentration cause the wall of the convoluted tubule and collecting duct to be less permeable to water. Less permeable to water, it will lead to lesser reabsorption of water. So sometimes you do question, don't be heavily rely on the mark scheme because sometimes they are wrong lah. So you have to know what's right and what's wrong lah. If you suddenly sense like, why they are the same thing? Yeah, probably something wrong lah. So not all the time mark scheme is correct. If you're not sure, you can actually check with your teacher lah. Yeah, don't be afraid to lecture your teacher and ask questions. It's your most important period of the time lah during the few days before SPM. So yeah, and what results in the urine condition, high volume or less concentrated volume is produced. Yeah, so this is basically how you mention blood osmotic pressure comparison lah. Okay, so now let's move on to this Pahang paper also talking about the same thing. But this one they very good lah. They show afferent and efferent in a more clearer picture lah. Because just now I very hard to show you the difference in the diameter. But the diagram also didn't really show that diameter is a different size. Because it's very small lah. So yeah. But basically the diameter. Okay. So the starting of the blood vessel right here lah. Okay, is the afferent arteriole. And then after afferent, then this one glomerulus, then go out. This one is the efferent arteriole. So the reason why the blood enters in the glomerulus in such high hydrostatic pressure is because afferent arteriole, the diameter, the afferent arteriole is larger than the diameter of efferent arteriole. So yeah, this one is also the same thing now. This is the this is the glomerulus, and then process X is ultrafiltration. This one is Bowman capsule, okay, and then followed by your proximal convoluted tubule, and then it will enter to one big loop. It's called a loop of Henle, and then that's where proximal convoluted loop of Henle, all this reabsorption occur. And followed by your distal convoluted tubule, and then enter your collecting duct, and ta-da, pass through the urine. So what that occurs in between glomerulus and Bowman capsule, ignore the Bowman again. Yeah, it's basically ultrafiltration. So answering this, right, you don't really mention what happens in the process X. Normally, I say question, you name the unknown, you get marks already. So you name what is process X, it is ultrafiltration. And you explain it. Yeah. It's also the same thing like I mentioned just now, so I'm not gonna waste time already lah. So this one is also the same thing lah, talking about blood osmotic pressure. So mechanism of water regulation in individual A and B. Yeah. Okay. This guy, he drink a lot of water lah. So and yeah, so this one you explain the condition first. This one he drinks a lot of water. This one is loss of water due to extreme hot weather. Then cause your blood osmotic pressure to blah blah blah. Then osmoreceptor blah blah blah. Okay, this part because I copy from just now, so yeah, that's some small. Okay, yeah. So basically, this is how it looks like lah. So I will actually post the resources via a Google Drive link where I put it in a link in description below of this YouTube video, so you don't have to worry you sempat copy or you have to keep pausing the video to copy it. Okay, so the answer will be provided. Just that you be in mind that sometimes the mark scheme may be false lah. Like this one, I didn't expect it to be mentioned wrongly lah. Okay, this one diagnosis for diabetes mellitus patient can be carried out through urine test to identify presence of glucose in urine. Like what I mentioned just now, why the urine suddenly got you glucose? I thought it's supposed to be 100% reabsorbed in the proximal convoluted tubule. Yeah, but this guy got diabetes mellitus. So too many glucose already, no choice, can't be fully reabsorbed. That's why end up discharge through the urine. So explain why urine contains glucose. Okay, so is you mentioned what happens in this diabetes mellitus patient first lah. Okay. Okay, diabetes mellitus, right? They actually got two type people lah. Two type of people. Two type of diabetes mellitus lah. Diabetes mellitus, you have to be specific. It is diabetes mellitus, not diabetes insipidus lah. So you have to write out the mellitus. Yeah. So type 1 is basically because of the pancreas. Yeah, failure of pancreas to secrete insulin. Okay, what about type 2? Type 2 is basically the body cell cannot respond or it is resistant to the insulin. So normally lah, type 1 is due to like genetic factor lah sometimes, or maybe that person born and then already got this mutation lah, got this issue lah, whereby the pancreas fail to secrete insulin. But type 2 is normally due to our lifestyle one lah. Normally lah. Yeah, I just talking majority lah. So type 2 is normally due to lifestyle, like you consume a lot of sweet stuff, okay, sweet drink, a lot of high glucose content food lah. So your pancreas will, of course, it will keep secrete insulin. But now your body cells, right, it will like, because insulin is the one that um sti stimulates lah this process where your glucose to be converted to glycogen lah, excess glucose to be converted to glycogen, or stimulate your body cell to use this glucose for aerobic respiration. Yeah, but now the body cells fails to respond to it lah, because yeah, the insulin keep producing since you keep eating sugary stuff. So eventually one day it starts like, oh, hanky liao, okay, malfunction like that. So it kind of not effective when in responding to the insulin. So less, so the glucose can't be like converted to glycogen, or the glucose won't be utilized lor. So end up your body still got a lot of glucose. Glucose is still in a high range. Yeah, above the normal range lah. So that is the difference between type 1 and type 2. Okay, but the answer scheme just mentioned about type 1 lah, because it's quite direct way of answering it is a failure of pancreas to secrete insulin. But there's actually another way, a type 2 diabetes mellitus patient is whereby the body cells fails to respond to the insulin effectively. Better to write effective lah. Not directly fail to respond, is yeah. Okay, so excess glucose does not converted, because insulin is the one that helps the conversion of glucose to glycogen. Yeah. So now it fails to secrete, so the glucose cannot convert. So causes the glucose concentration to still become very high. And okay, this is basically explaining about the diabetes mellitus patient condition, why the glucose very concentration is so high. And then we can mention what happens in the nephron, which is the proximal convoluted tubule. In a normal situation, it will be 100% reabsorbed. Glucose will be reabsorbed. But now it fails to fully, because you didn't mention fails to fully lah, not 100% to be reabsorbed in the proximal convoluted tubule. You have to be specific, is at the proximal convoluted tubule. That's the reason why the glucose will be discharged in the urine. It will be secreted in the urine. That's why glucose present in the urine. Thus, glucose present in the urine. That's how you answer back to the question on explaining why urine of diabetic patient contains glucose. Yeah. First of all, mention what happens to this diabetes patient. Why they cannot how to say this, metabolize the excess glucose into glycogen because pancreas fails to secrete insulin. And then what happens to this leads to that's the reason why it's still very high concentration of glucose. And then yeah, when too high already, too high that they memang cannot be absorbed, the proximal convoluted tubule right there, memang cannot be absorbed fully lor, so unable to fully be absorbed, causes the glucose to be secreted in urine. Yeah. And last but not least is basically this glucose test. This one is in Selangor set to paper. Yeah. He ate a plate of fried rice and a cup of coffee for breakfast, shows the level of sugar in her blood, a normal blood sugar reading in between 75 to 100, but hers is higher than the normal range. Oh no. Hey, by the way, the coffee, right? It will actually, I mean, this one extra info lah. It will actually inhibit the release of antidiuretic hormone. So if you recall back to this concept lah, when there's a low antidiuretic hormone means lower the absorption of water. So that will cause your urine produced to be high in volume, right? So if you, because maybe lah, you try to think of this situation, or maybe you just straight away drink a lot of coffee lah. You tend to have a higher volume of urine. You tend to go to toilet. Yeah. You tend to have a higher volume of urine. You always want to go toilet lah, okay, to pass out the urine. It's basically because of the coffee, it inhibits the secretion of antidiuretic hormone. That's why lesser reabsorption of water. So most of the water being end up in the urine. So high volume of urine makes you always want to go toilet when you drink a lot of coffee lah. That's something lah. An extra info in case they ask in the K-Bar question. Okay. Alright. This going back to this question. Yeah, her blood glucose level 保 higher than normal range. Okay, so homeostasis process occur to regulate the blood sugar level of the student back to a normal level. Okay, actually, in normal situation, yeah, she doesn't have diabetes mellitus because this is a normal situation after she took her lunch. Mama, after she ate a plate of fried rice. So, you know lah, fried rice, high carbohydrate content. Yeah, it broken down become glucose. So the glucose tend to spike in level lah, tend to be above normal range. That's why we have this insulin lah. So it's normal lah, okay? Don't have to panic that she got diabetes first because they say homeostasis process to regulate it. Okay, it's not about diabetes. So yeah, blood sugar level increase. So what cell will be stimulated to produce insulin is actually beta cells in the pancreas. Yeah. Okay. Alpha cell, I read it, is alpha. Alpha cell is the glucagon. But beta cell is actually insulin lah, so don't get messed up lah. Yeah, to secrete insulin into blood, that's why excess glucose converted to glycogen means the excess. So that's why now the glucose level will be dropped lah, and glycogen stored in the muscle cell. Then insulin also converts the glucose, excess glucose to fat. Yeah, and also stimulates respiration in the muscle cell. So in order to answer back to the question, thus blood sugar level returns back to normal range. To normal range. I mean, it's better lah if you write the last sentence, even though you won't get point. I mean, sometimes you get lah, it depends lah. But normally you write it to make sure that you answer the question. Make sure like, oh, it's in one whole process. So you get answer back to the question. The osmosis in order to regulate blood sugar level back to normal range. Normally you won't get mark lah because you already mentioned regulate blood sugar level back to normal range. But normally I like to do I have this habit of writing in the last sentence to ensure that I got answer back to the question. Okay, imagine you suddenly write about glucagon and then you realize, how I mean it returns back to normal range, but you realize something wrong lah when you are mentioning the blood sugar level because initially it's very high. So you want to reduce it back to the normal range. But you keep, if you talk about glucagon, then you keep mentioning, you make it glucose level high again. So something wrong. So yeah. So yeah, that's all for today. I know it's a very long discussion. So yeah. Thank you so much for your overwhelming response. Yeah, so if you need me to make more videos regarding to this revision, you can actually comment down in the section below, or if you have any questions to ask or anything I mentioned wrongly, don't forget to let me know. So yeah, that's all for today. Thank you so much for watching this such long video. And yeah, good luck in your SPM design for tomorrow. Yeah. Okay, bye bye.